Have you ever thought about whether we're truly alone in the universe or if there's more to our existence than what we see? What if the James Webb Telescope finally proves that we live inside a black hole? Join us as we explore this groundbreaking news that might make you question everything you thought you knew about the universe. So, what exactly are black holes? They're like something out of a nightmare. Sure, you might have seen them in sci-fi movies, but the reality is even scarier. According to scientists, black holes are not just pitch-black voids in space. They are actually massive amounts of matter squeezed into an incredibly small area. Imagine a star 10 times more massive than the Sun, all packed into a sphere the size of New York City. The gravitational pull is so intense that nothing, not even light, can escape from it. Scientists have been fascinated by black holes for centuries, ever since they pondered objects in space so massive and dense that they could trap light. The most famous ideas about black holes were predicted by Einstein's theory of general relativity. Essentially, when a massive star dies, it leaves behind a tiny, dense core. If this core's mass is more than 3 times that of the Sun, gravity overwhelms everything else, leading to the formation of a black hole. Detecting black holes is no easy task since they don't emit any light. However, scientists have found ways to infer their presence by observing their effects on nearby matter. For example, if a black hole passes through a cloud of interstellar matter, it will pull that matter towards it in a process called accretion. Additionally, when a normal star gets too close to a black hole, it can get torn apart, emitting X-rays as it does so. Black holes also have a significant impact on their surroundings. They can consume nearby stars, emit powerful gamma bursts, and even influence the growth of new stars in some areas while stalling it in others. But where do black holes come from? Picture this. Stars, once magnificent and blazing, meet their ultimate demise in a spectacular explosion called a supernova. From the remnants of these fallen giants, black holes emerge. Most black holes are born from massive stars that have reached their celestial retirement party in a supernova blast. Smaller stars, when they die, transform into something called neutron stars, which are super dense but not dense enough to trap light. However, if a star is about 3 times the mass of our Sun, it collapses under its own gravitational pull, forming a black hole. As these mighty stars collapse, something strange occurs near their surfaces. Time itself starts to play tricks. From the perspective of someone far away, time appears to slow down near the event horizon, the point of no return for anything falling into a black hole. It's like the star's clock ticks at a different pace compared to ours. Sometimes, when 2 smaller black holes collide, they combine to form an even bigger and scarier black hole. And if a black hole teams up with a neutron star, they create a colossal nightmare that defies comprehension. Scientists have been grappling with the scale of these cosmic phenomena for years. Black holes come in 2 sizes, huge and small. There's a sinister mystery surrounding them that we can't seem to unravel. But here's the twist. Small is relative when it comes to black holes. Stellar mass black holes, remnants of massive stars, can be as large as 10 to 24 times the size of the Sun. There could be as many as 10 million to a billion of them in the Milky Way alone. That's an astronomical number of black holes that could swallow anything in their path. But wait, there's more. Supermassive black holes are on the other end of the spectrum. They are millions, if not billions, of times larger than the Sun. They exist at the center of large galaxies, including our very own Milky Way. It's like a gaping dark void that's pulling everything towards it. Renowned physicist Stephen Hawking talked about black holes in his lifetime. His lectures were always insightful, but some of his theories couldn't be confirmed due to a lack of necessary equipment. However, there's hope on the horizon. A single scientific instrument is changing everything, and we might not be ready for it. It goes by the name of the James Webb Space Telescope, also known as JWST, and it's here to plunge into the depths of our universe. The JWST is no ordinary telescope. It's an engineering marvel, a testament to the potential of human ambition. Sure, we've launched other space telescopes before, and they've been doing their jobs just fine, but this one is in a class of its own. The JWST makes the Hubble, which has dutifully served us for years, look like a mere speck in the cosmos. The price tag of this astronomical wonder is a whopping $10 billion. Yes, you heard that right. That's enough zeros to make your head spin. And get this. It took the combined efforts of NASA, the European Space Agency, and the Canadian Space Agency to bring this marvel to life, not to mention the invaluable input from over 300 universities. But let's not forget the risks that come with such a grand undertaking. I know this isn't a venture for the faint of heart. The JWST is venturing into uncharted territory, pushing the boundaries of what we know, and taking us to places we've only dreamed of. Following a successful launch, NASA recently announced that the telescope has enough fuel to last more than twice its minimum mission life expectancy of 10 years. Since its launch, the JWST has achieved many incredible feats. It traveled over 1 million miles to reach its orbit around the Sun, where it will reside permanently. During its journey, the telescope successfully unfolded its massive 5-layer sun shield and giant main mirror, both of which had to be folded to fit onto the launch vehicle. Now, after NASA has fine-tuned and calibrated it, the telescope is almost ready to go into full operation. One of the most exciting things about the James Webb Space Telescope was when NASA announced that it had captured its first images of starlight. The first image taken by the telescope was of a star called HD 8446, resulting in a mosaic of 18 scattered bright dots from the star's light, captured by the 18 mirror segments located on the primary mirror. NASA later released a new and improved image of HD 8446, in which 18 unfocused copies of the star were brought together in a deliberate hexagonal formation. Once the observatory successfully aligns the individual segments of the primary mirror, it will begin the image stacking process, bringing 18 images on top of each other into one clear view. Thanks to its sophisticated technology, the JWST will help scientists investigate the early stages of the universe after the Big Bang. It will study what happened after the first stars formed, a period known as the epoch of reionization. This era refers to when neutral hydrogen was reionized, or made to have an electric charge again, by radiation from these first stars. This involves looking back billions of years, which is only possible with a powerful telescope like the JWST. The telescope will also help scientists discover exoplanets, which are very difficult to spot because of the way they interact with their host stars. Its powerful sensors will be able to observe these planets in more depth, including, in some cases, imaging their atmospheres. Understanding the atmospheres and formation conditions for planets could help scientists better predict if certain planets are habitable or not. Apart from studying the assembly of galaxies, scientists study galaxies to see how matter is organized on a gigantic scale. This, in turn, lets us see how the universe evolved. The spiral and elliptical galaxies we see today evolved from different shapes over billions of years. One of JWST's goals is to look back at the earliest galaxies to better understand that evolution. Scientists are also trying to figure out how we got the variety of galaxies that are visible today and the current ways galaxies form and assemble. However, most importantly, the James Webb Space Telescope will help us answer the most profound questions of all. Are we alone in the universe? And are we living inside a black hole? The JWST has already been on the hunt. And guess what it found? Compounds called polycyclic aromatic hydrocarbons, PAHs, lurking around those gigantic supermassive black holes in 3 active galaxies. PAHs, these carbon-based molecules with ring-like structures, are like the goth kids of the universe. They're everywhere, from distant galaxies to comets in our solar system. Now, they're not just fascinating because they could be the building blocks of life, but also because they help astronomers track star formation. When ultraviolet radiation hits these PAHs, they go all flashy and emit infrared light, a sight that can be detected by the JWST's mid-infrared instrument, MIRI. This is usually a sign that there are some hot, young stars hanging around. But wait for the plot twist. A brave astrophysicist, Ismail Garcia Bernard from Oxford University, decided to take a peek at 3 active galaxies known as NGC 6552, NGC 7031, the spookily famous Stephan Quintet, and NGC 746. These galaxies are millions of light-years away in the depths of darkness. Now, what Garcia Bernard discovered will make your hair stand on end. In those central regions where the black holes reign supreme, MIRI found an abundance of PAHs. Sounds good, right? Well, here's where it gets chilling. The radiation near those supermassive black holes twisted the PA's very essence, transforming them into larger, electrically neutral versions of themselves. The smaller, electrically charged PHs vanished into oblivion, like being devoured by the darkness itself. But wait, there's a glimmer of hope. The larger PAHs managed to survive because they found shelter within. Thin, dense, gas-filled clouds. It's like they found their own protective hiding spots. So, while supermassive black holes are supposed to gobble up everything around them, they leave some clues behind, like footprints in the cosmic sand. I know what you might be thinking. If black holes can do all of this, could it be possible that our universe is inside a black hole? Could the answer to the question that has plagued humanity for eons finally be at our fingertips? With the James Webb Space Telescope, we may soon find out. The telescope will dive deep into the mysteries of our universe, and who knows what it will discover next. As the James Webb Space Telescope, JWST, continues its mission, it holds the promise of revolutionizing our understanding of the cosmos in unprecedented ways. Beyond the immediate discoveries of black holes and distant galaxies, the JWST is set to address some of the most profound questions about the universe's origins, its structure, and our place within it. One of the most intriguing areas of research involves the study of the early universe. The JWST's advanced capabilities allow it to peer further back in time than ever before, potentially observing the formation of the first galaxies. These early galaxies, often referred to as cosmic dawn, played a critical role in shaping the universe as we know it. By analyzing their formation and evolution, scientists hope to uncover details about the processes that led to the creation of structures we see today. Moreover, the JWST is equipped to investigate the formation of stars and planetary systems. Its infrared capabilities are particularly suited to penetrate the dense clouds of gas and dust that often obscure these processes from view. By studying these regions, the telescope can provide insights into the conditions that lead to star and planet formation, including the potential presence of complex organic molecules that might hint at the building blocks of life. In addition to its exploration of star formation, the JWST is also poised to make significant contributions to the study of exoplanets. The telescope's sensitivity to infrared light allows it to analyze the atmospheres of exoplanets in detail. This can reveal crucial information about their composition, temperature, and even the presence of potential biosignatures. For instance, detecting water vapor, methane, or oxygen in an exoplanet's atmosphere could suggest conditions that are conducive to life. This capability is particularly important as scientists seek to identify planets that might be similar to Earth, which could harbor life or offer insights into the conditions necessary for habitability. The telescope's observations extend beyond individual stars and planets. By examining the large-scale structure of the universe, JWST will help scientists understand the distribution of dark matter and dark energy, two of the most mysterious components of the cosmos. Dark matter, which does not emit light or energy, can only be detected through its gravitational effects on visible matter. Dark energy, on the other hand, is thought to be responsible for the accelerated expansion of the universe. By mapping the distribution of these entities, JWST could provide critical data to refine our models of cosmology and the universe's ultimate fate. JWST's capabilities also include studying the chemical composition of distant galaxies. The presence of certain elements and compounds in these galaxies can give scientists clues about their history and evolution. For example, detecting heavy elements like iron and nickel can indicate the presence of supernova explosions, which are responsible for creating many of the elements found in the universe. By analyzing the chemical signatures of these galaxies, scientists can piece together a timeline of galactic evolution and better understand the processes that led to the formation of the universe's complex structures. Another fascinating aspect of JWST's mission is its potential to explore the concept of cosmic inflation. According to theories of cosmic inflation, the universe underwent a rapid expansion just after the Big Bang. This theory helps explain some of the uniformity observed in the universe today. The JWST's ability to observe the very earliest moments of the universe could provide evidence for or against inflationary models, offering deeper insights into the conditions that prevailed immediately after the Big Bang. The telescope's role in understanding black holes extends to examining their influence on galaxy formation and evolution. Black holes, particularly supermassive ones at the centers of galaxies, can have profound effects on their host galaxies. They can drive powerful outflows of material that influence star formation and the growth of the galaxy. By studying these interactions, JWST can help clarify how black holes and galaxies co-evolve, potentially uncovering mechanisms that regulate galactic growth and star formation. Furthermore, JWST's observations will contribute to the study of cosmic voids, vast, empty regions between galaxy clusters. These voids are important for understanding the large-scale structure of the universe and the distribution of dark matter. By mapping these regions, scientists can gain insights into the underlying forces that shape the universe's structure and how it has changed over time. As we look to the future, the James Webb Space Telescope represents a new era in astronomical observation. Its advanced technology and unprecedented sensitivity open up possibilities that were previously beyond our reach. Each discovery made by JWST has the potential to challenge existing theories, inspire new questions, and expand our understanding of the universe. In summary, the James Webb Space Telescope is not just a tool for observing distant galaxies or analyzing the atmospheres of exoplanets. It is a key to unlocking some of the most profound mysteries of the cosmos. Its observations will deepen our understanding of the universe's origins, its fundamental components, and the processes that govern its evolution. As we await the discoveries to come, the JWST stands as a testament to human curiosity and the relentless pursuit of knowledge about the vast and enigmatic universe we inhabit.